Hi everyone. So, in the last session, we left off with poker hands. We just described what the different hands are. Today, my goal is to describe poker probabilities, right? That's what the series is about. It's a quick series about odds in poker, right? So now let's start with the one pair. Let's recollect that the total number of hands is around 2.598 million, right? Total number of hands is 2.598 million. That means out of all the poker hands, I can have 2.598 million hands. Now I need to narrow it down. My goal is to count or figure out the numerator. I need to count how many one pairs are possible, right? Now, when you get a one pair, you need to break the probability down. You need to break it down into parts. And this can be a little irritating, but let's try. So I'll write the formula down. I'll write the system down first. It's 13 choose 1 into 4 choose 2 into 12 choose 3 into 4 choose 1 into 4 choose 1 into 4 choose 1. Okay, now this looks very drastic and pretty big, the formula, right? But let's break it down into sequences. When I look at the screen, I want you to read these two parts separately, right? Read this is part 1 and part 2. Remember, your goal is to create a pair. So what this is saying is, to create a pair, I need to first select one card out of the 13 possible, one different card, or let's say one different rank. To create a one pair, I need to select one rank. It can be any rank, it can be ace, 6, 5, king, whatever you like. But I need to select one rank, right? So let's assume that I select the ace. So out of the 13 cards, I select the ace. Once I select the ace, I'm then restricted to the ace, right? How many aces are there? There are 4 aces, right? And out of the 4 aces, I need to select 2 aces, right? Remember, I'm first selecting a rank. This is me selecting a rank. Once I select a rank, then I'm restricted by that rank. So I need to select 2 cards that belong to the same rank. So after selecting an ace to make a pair, I can't go and select 4 random cards. I'm constrained to the aces. For the second part, I can select any random card. I can select 3 random cards, in fact, right? But I can't select an ace, which means I have only 12 choices. I can select only out of the 12 ranks, that is, the 12 remaining ranks, right? How many cards do I need to select? I need to select 3 cards. Now, out of 3 cards, I have 4 suits, right? So, out of the 4 suits, I go and select any random card from each of the 4 suits. Random card from each of the suits. So for example, I can select a 6 here, I can select a 5 here, I can select an 8 here, it can be an 8 of hearts, it can be a 5 of hearts, then it can be a 6 of diamonds. But here I have an ace and an ace, right? This gives me the one pair, and then you have 3 random cards. When you calculate this out, you get 1.098 million. Approximately, I'm not going into the decimal places further, right? When you divide this, now here I found out the total number of hands in a one pair, that is 1.098 million. When I divide this by 2.598 million, I get the probability of a one pair. So the probability of a one pair. Now this is a fun division. I'll leave you guys to do this calculation. I don't want to leave everything final. You can go do some exercises yourself. 1.098 million divided by 2.598 million. Answer to the question, the probability of a one pair. Let's take the next one, the two pair. Now in a two pair, we use the same logic, right? You have 13, choose 2. Why is it 2? In the previous one, if you notice, there's just 1, right? Because I had to just pick out of the 13 ranks, I had to pick one rank. In case of a 2 pair, I need to pick 2 ranks out of the 13 total ranks. Out of the 13 ranks, once I pick 2 ranks, then I'm constrained by the suit, right? So instead of writing the square, you can write it this way. This means I need to multiply this twice, right? So what this term is saying is, out of the 4 different suits, I need to pick any 2 suits. Any 2 suits. The rank, remember the rank is fixed. So I can pick, once I pick an ace, I need to pick another ace. Of course, I picked 2 ranks, right? So I've picked, let's say I picked an ace and a king, then I need to pick another king, right? Which means I can pick any 2 suits. The suits don't matter. I can pick hearts and a diamond, or a spade and a clubs. That doesn't matter. But you are constrained by the ranks first and then the suits. The last card, how many suits, or rather, how many ranks are left? You have 11 ranks that are left, right? Out of the 11 ranks, you just need to choose one card. It can be anything, right? You need to choose one rank. Out of that, how many suits do you have? You have 4 suits. So you get a pattern here, right? You first need to select the rank and then the suit. Rank and then the suit. Remember that this is the key to understanding poker probability. Yeah. In poker, you would have realized that there's a pattern to the counting, right? You first pick the rank, and then there are ways to pick the rank. You don't need to pick a particular suit itself, unless you have a royal flush or something where you're constrained, right? So you can pick the rank and then the suit. So i- i- when we did the 2 pair, I first picked 2 ranks. That is, out of the 13 ranks, I picked 2 ranks, but I could have picked any of the 2 cards from the 4 suits, right? So you first constrain the rank and then you go to suits. So how many ways are there to count the rank and then the suit? You break that down and you finally get the probability. Now, here, the total number of ways in a 2 pair, so the 2 pair probability finally comes out to 123,552 divided by, remember the total number, 2.598 billion. So again, I'll leave you guys to calculate the final number. It's just a simple division. You can take your calculator out and you can get a final number. But the idea is realizing that the numerator, if you realize in 1 pair, the numerator was close to 1.1 million, whereas in a 2 pair, it reduces to 123,000. Now there's a drastic reduction there, right? It's shrunk quite a bit. That's because in poker, with each hand, right, with each type of hand, your probability of getting that hand decreases, and that's what determines who the final winner is, right? Okay, let's go to the next hand. That is 3 of a kind. I'll do something interesting a little later with you guys as well, where I'll actually do the counting part and reduce it and show certain things to you where the counting becomes easier. I will show it to you or demonstrate it with probably in the next lecture in this 4-5 part series. I will demonstrate how you can count by breaking it down further. As of now, I've just left it to the combinatorics. I will break it down even further. So let's see, 3 of a kind. So in 3 of a kind, if you remember, I need to choose, it's 3 of a kind, right? Which means out of the 13 ranks, I need to choose one rank out of the 13 ranks. Once I choose that, I can choose from any of the 4 suits. I can choose 3. From the 4 suits, I need to choose 3 after picking a rank. For example, if I choose an ace, I can choose the ace of hearts, club, spades, the ace of diamonds, club, spades. So there's a choice there as well. So these two interact with each other. Rank into suit. Remember, rank into suit. That's the easiest way to remember poker probabilities, right? Now the last two cards that you pick can be random again. So once I constrain one rank, I have 12 other ranks, right? So I can't pick the same rank. What happens if you pick the same rank? In fact, if you pick the same rank, then it becomes four of a kind, right? If I pick three, then it's three of a kind. But if I don't constrain that, if I say, you know what, let's say instead of 12, I use some other number here like 11. It sort of it's sort of a miscalculation, and students generally make this mistake uh, when I do combinatorics with them. They kind of miss the fact that once I constrain the rank and the suit, right, I need to think of what the hand that I'm looking at is. So it's going to be different for three of a kind and four of a kind, right? So here I have 12 and I need to pick two, right? Because it's three of a kind, the last two cards can be random, and out of four suits, I can pick anything, right? So again, it's rank, suit, suit. So the last two, 4 choose 1 into 4 choose 1, that represents that I can pick any suit, whereas 12 choose 2, which is the first part, represents that I can pick any two ranks, it's random.